Okay. Just going to go over those. And I think it's important to actually take a look at these to see how much or how, what do I want to say, how far we've come this semester, how much you've learned, because not all of this pertains to what we've done in this chapter. So if you choose, go ahead and write some of that content down. If you don't feel so inclined, and that is your choice. It gives you somewhat of an idea how well you may or may not understand this content. Well, and where possibly you're sitting. And something to think about is when this arises in, is it a week, 2 weeks from yesterday would be the final in here. Maybe not everyone's required to take that, but also keep that in mind as well, please. Now, the third one down, I realize there's a gap because I want us to think about that, to start with benzene and get all the way over to what looks like propylchlorobenzene is what I believe you would call that. And who knows? You may have some of these reactions in your notebook already, but good. And hopefully it'll be maybe that much simpler. Maybe yes, maybe no. So we'll give you a couple more minutes to go ahead and do that. I don't think we want to go too far zooming in. Okay, I think that's probably just fine. The top one is probably one of the very first reactions or equations we would have gone over. Well, probably if we had a halogen here instead, like bromine, iodine, or chlorine, would have been the very first one. And this probably came later in Chapter 3. So the top one's from Chapter 3. The second one is from Chapter 5. The third one's from Chapter 4. And then the bottom one here again is from Chapter 5. And before we go, I'll make sure we collect those papers and continue to move forward. Okay, so that top one. First of all, what is the name of the reactant that we got the reactant here. What is that compound? Okay, a little more specific. 2-pentene, okay? Remember when you're naming these, just like we would have down here, if you're not writing anything after the number, you're saying we're either an organic family is or where a double bond is. Okay. And as that looks right now, that will not react. Right now, it's no reaction. How can we change that to a reaction? Okay. So there's a variety of catalysts that we could use. And the two most common was going to be either UV light or heat. So if we put heat as a catalyst, that will cause that hydrogen to then attach to here. And this 2-pentene gets changed to what? Now what do we got? Pentane, okay? So alkenes can be changed to alkanes, providing you have a catalyst. And the reason because of that is, remember, that bond is really, really unstable. But this is an exception to that rule. It has to have a catalyst. Okay? Now, if we were to take this off, okay, and like I said, if we had a halogen here, would that need a catalyst, do you think? Because what's an exception to the rule? It means it's kind of like one that really doesn't want to play with the rest, if you want to call it that. Hydrogen needs a catalyst. Halogens do not. Okay? So the only thing that would be different is we would have a fluorine there and a fluorine there. Okay? And, I'll just put them both on the bottom. It's typical. Well, you got to remember these are in 3 dimensions. Okay. Then next, what is that called? We're getting better at that because usually when we start as freshmen, and then sometimes when we're juniors too, we do this, and everyone's good at going, all nodding their head because they're counting as they're going. It just gives me a cruel chuckle. Maybe I'm guilty too. Yes, same parent chain because it's 5, and then yes, we would say 3-pentanol, but what's probably more important than just knowing that this is 3-pentanol? If you put an X up there, how many times did we use that variable X, and why? That's exactly what we're referring to, yes. And it is a secondary. Why are you correct? Because this guy, okay, is attached to 2 other carbons. Now, okay, because if we had this 3-methyl-3-pentanol, that totally changes the complexity of this because as far as dehydration is concerned, will this react then with a tertiary alcohol now? No, it will not. Tertiary alcohols don't dehydrate and they don't oxidize. Okay, so this will dehydrate now, okay? Don't for instance do this. Now we're saying don't do this. Oops. Oops, I put it on the wrong one. Glad I caught that before anybody said anything. Why would we say don't do that? Because this is a result of a secondary alcohol, but what's wrong with the process? So it does. I was just seeing if anybody's paying attention. But that still would not be correct, though. Because we're making you think here. Why can we not get this? There's something on that side of the reaction that's the problem. And this will come with experience, okay? Because sulfuric acid is known as a what type of catalyst? Maybe it doesn't add water, it does what instead? And when you lose water, what's that called? Yeah, this is a dehydration reagent, not an oxidizer, okay? Because if you look on your paper that you're about to turn in, you're going to see secondary alcohols that are reacting with this or these are your two oxidizing agents, okay? If one of those two is present, then you're going to get this 3-pentanone. But H2SO4 or sulfuric acid is a dehydration reagent. So if that is the case, which it is, how do we correctly write this then? We've got everything we need over there. What happens when things get dehydrated? You correctly said you're losing what? We're losing water, and you're going to find out that how we're ending this semester and beginning the next one, it's all about the water, okay? The reason we say that is on that side, here's half of it. I guess I should include the bond with that. Okay. Here's half of it, okay? So then at this point you say left or right. Okay? So then there's our water that is now gone. Then the last thing we need to do is just put the correct bonds in. So that one's there. There we go. Okay. Very good. And then just make sure you get one of the products up here, okay? Because what can happen is this double bond could also be well, that would be the same compound, sorry. So yes, you would only have just this one product. Okay. With what we've done so far, any questions with, because we're doing kind of like a whole semester type review here. Okay? And this isn't meant to say, ha ha, we got you. Next time I see Ms. Doctor, I'll say, that's what you do in math class. Ha ha, we got you. We don't do that in science class. Maybe we do. I don't know. Ha ha ha. All together, ha ha ha. Okay. Fair enough. So we're halfway through. All right. Would you rather go through this bottom one first? Because this one's a little older. This is from last chapter. Would you rather do the current content? Okay. So now when we look at this, okay, we've got 2-butanol. Why is that important, first of all? Because we said when it comes to alcohols, make sure we know what. See, they're excited across the hall, too. Maybe they saw Stuart outside. I don't know. Ah, it's a minion. Yeah. All right. Okay, so we got this 2-butanol. Okay. So what type of alcohol is this? Just like this one was. It's a secondary. Okay. And what type? We're not dehydrating it. We're doing what instead? This is a what type of reactant? Starts with an O. Yeah, it's an oxidizing agent. So what happens to secondary alcohols when they get oxidized? They form what? It'll unlock a door. Yes, it'll form ketones. Well, I don't know if the ketone will let you in, but yeah. Okay. So how do we correctly write that? The dashes on there aren't very good, I realize. What happens to that hydroxy group? It turns into a double bond. That hydrogen just says, huh, I don't want to be part of this, and just double bond me then. Yeah. The only last thing I'd want to go over is, okay, how would this be different if we took 2-butanol and changed that to propanol now? How might that, so this one's gone now. Does it stop there? Would this reaction stop here? No, it doesn't. Because what do we have right here? We got a carbonyl carbon, because we got a double bonded oxygen. And what is this called right now? It's in what type of organic family? Well, that's the parent chain. It's Tim's assistant on Home Improvement. Who's Tim's assistant on Home Improvement? Al. So there, if we're talking about Al, this is what type of organic family? Propan, that's an alcohol. Al, propanal. Yeah, propanal. Were you saying propanal? It sounds like you're saying OL instead of AL. You probably say soda too instead of pop. Oh, okay. All right, fair enough. But this aldehyde does not stop. It keeps going, does one more step, and creates what? Not propanol, goes one more, and this gets attached to it. Now, we're under the presumption that you're going to write this one more time, and that propanol gets changed to that organic family, which is what? COOH. Propanoic acid, carboxylic acid. All right. Can we erase this content then? Okay. Keep in mind, we do not have class in here tomorrow. Okay, so that'll be pertain to out in the gallery as well. I believe you are taking in what's called NCRC type of, I believe it's tomorrow. Maybe I'm incorrect. Okay. Okay, notice we got some gaps in there. Are we looking at this and just saying, oh gosh, I used to know how to do that? Okay, well, the first thing, we're starting with benzene. First of all, we've got to get that propyl group on there. That's the very first thing we need to do. So in order to do that, we're going to react it with a 3-carbon, okay? Could we just react that with propane, do you think? And again, this is where your chart would help you, if it does. And if we're under the presumption that this chart doesn't help me, we're trying to fill that in. I don't know what else to do. But you wouldn't have to erase anything if you put this down. Just need to make an addition on here. we can do anything out of column 7. So any halogen. Okay? Since we got chlorine on there, that's fine. You can put iodine, bromine, fluorine on there, any one of those, because remember, on your chart, we're starting with benzene, that's in the clear middle, and what you're doing is any carbon compound is R, any halogen is X. So upon doing that, do we need a catalyst here? Will this react? Because remember, double bonds are highly, highly unstable. But what's true about benzene, though? Is that unstable? No, it is highly stable. So we'll just add some nickel bromide. Well, I guess maybe it should be nickel chloride, because I think we've been in that habit. We just still use the same halogen. Okay? So now that we've got this on here, what is a result of this? Other than we want you to draw a better 6-sided figure than that. Your chart tells you when you've got this R and X, what ends up getting attached, the R or the X? The R does. So in that case, what that means is this is now gone. Okay? How do you cross off an X? We may never know. Because we just do it. Okay. So what does that mean? We attached. I just never thought of that till just now. How do you cross off an X? Oh, okay. Now it looks like a railroad crossing sign. Anyway, so that's now gone. Okay, we should take the bond with it, or I guess we don't have to. Okay, yeah, I guess we should. Because now what do we have attached to here? Okay, I would really, really not recommend this unless you have a really good understanding. Okay, don't do that. That's too many bonds. Okay, the best way to look at this would be what? Rather than doing the molecular formula, doing what instead? Okay, that's why we're crossing that off. So you will not be wrong. It'll be more apparent when you do that. Okay, remember that bond got taken away. So we now have a carbon-to-carbon bond, not a carbon-to-chlorine bond. Okay. Now, the last thing, how do we close this gap? We really got to be careful with how we do that. Because if we react that with this, with, what do I want to say? Even if you react that with chlorine to get that attached on there, that's fine. But it's how you react that. You got to do something very specific. Why do you have to use heat? What happens if you use some more nickel chloride again? What would it tell you? So we're reacting this with chlorine. If we use another metal catalyst, we're going to end up with 2 products. We don't want 2 products. Because what that's going to tell you, if we react this with heat now, this is going to be forced to attach onto here. Okay? So then notice with what we have here, 1, 2, 3, 4, 5, 6, 7, okay? And again, if you had that molecular formula, what's wrong with that? Again, you got too many bonds. It can't do that, okay? So you can write that as C3H6Cl, or those mean the same thing. We're not saying this is a meta director here. We're just showing you that it's sometimes better to use the molecular formula, or excuse me, structural formula as opposed to the molecular one. Okay. All right. Anything else? That's all I've got. We'll catch up to you next time.